So, to start with, it's odd and even functions. So I'm going to teach you how to do odd and even functions, but first, I want to make sure that you get what we've been doing so far. And the very first thing we did was domain and range. So I'm going to give you a picture, and I want you to tell me from the picture, what is that thing's domain and range? Go ahead, right now, on paper. Give it a shot. Range, the only kind we will ever give you are ones that you can make a picture for. You'll be able to make that little sketch based on your knowledge of, maybe it's quadratics, maybe it's absolute values, but you'll be able to make a little sketch like that. I hope you said from negative infinity to positive infinity for the domain, because it goes forever this way and forever that way without ever having any interruptions. Do you get that? Okay. And then the range is this way to this way, which is also negative infinity to positive infinity. Okay, good. Now, how about if it's domain and they don't give you a picture and you don't have any clue what it would look like? It could be something like this. Domain, you got to figure it out algebraically then. So, for that one, make a number line. Pick all the important points and put them on there. And then test the intervals. I'll give you a hint. So a lot of people forget this part. You don't just say 3 for the top. That is wrong. On the top, you say x minus 3 has to be greater than or equal to 0, and you solve it. The bottom is simpler, but all right, I'm going to pause for a minute while you work on those. So here we go. This one, you should have added 3x greater than or equal to 3, and 3 is on my list. I'm going to put it here. I'm not sure exactly where it should go. This one, x cannot equal negative 5. I know I kind of made the mistake of saying x equals negative 5 in the past, but that sort of implies that it should equal negative 5. What we're saying here is x cannot be negative 5 or this thing will crash. So here's a negative 5, and it cannot be that. I leave an empty circle. How about the 3? Can it be 3? Yeah, because it says we're equal to. So it can be 3. Another way to say it is if I put a 3 in here, it does not crash. It becomes 0 on top, but that's okay. 0 on the bottom is where you have a problem. And the last one is x cannot be 4. And then I put a 4 here, and then I say it cannot be 4. And now, how many of you had your points right? Raise your hand if you did. Okay, and that's going to happen again on the test. You're all going to probably have the points right. But then only half of you are going to actually test your intervals correctly. What you're testing for now is if I put in like 5, will this thing crash or not? So be careful. Test your intervals well and try to figure out which intervals work and which intervals don't work. Okay, we'll see which is the top half of the class here in a second. Test them. Test your intervals. Take 5. Stick it in to the red equation. See, does it work? Does it not work? Remember, all you're looking for is, does it crash? You're not looking for a particular answer. I'm going to pause again for... Here we go. Testing 5. Watch. Does that crash it? 5 minus 3? No. Does that cause a problem? No. Does that cause a problem? No, it works. That works. How about something like between 3 and 4, like 3.5? I know that seems hard, but it's really going to be very easy. I'm just going to toss in a 3.5. And does it crash here? Nope. 3.5 cause a problem there. Nope. 3.5 cause a problem there. It's negative. Is that a problem? No. It worked. Next, I'm going to test in this little zone. Ooh, my 0, my favorite thing. 0, 0, and 0 means negative 3 underneath the square root. Can't have that. Not allowed. Doesn't work there. And I think you'd find it doesn't work there either. Final answer should have been from 3 to 4 with a bracket, parenthesis, union 4 to infinity, like that. Raise your hand if you had that correct. Awesome. Okay. Now, your next step is the odd and even. No, we just did domain. We did. Oh yeah, Next step is we learned how to do these. And your calculator can tell you exactly where these points are if you know the name for them. What are those guys called? Maximums, local maximums to be exact. And that one? Local minimums. Okay, local minimum. All right, next, we just have to, let's say I tell you what those spots are. Let's say that this is at 4 comma 7, and this is at negative 1 comma 2, negative 1 comma 2 for that spot. And this spot here is at negative 3 comma 6. And this spot here is at 7 comma 0. All right. Which of those points is useless? 7 comma 0. It is not a low spot or a high spot. So therefore, when I'm asking you for like where are the increasing and decreasing intervals, you're just going to blow right past that one because it doesn't like change direction there. So there we go. The blue part I just described there. What's its interval? How would you say? I know it's decreasing. The question is, in what interval is it decreasing? 7 comma infinity, wrong. 4 comma infinity. Why? Because the 4 is the x. It's all about the x's. And why do some kids say that it's 4 comma negative infinity and they're wrong? Because it's going down and they think, oh, it's going to negative infinity. But really, the question is, from here to where, somewhere way out there, it is in the zone where it's increasing. And it's an x thing. So it's decreasing from the 4 to that way forever, which is infinity. All right, good. So that's the basics of intervals increasing and decreasing. Do you get that? Okay, good. Then the new stuff. Odd and even functions. First, I'm going to give you some pictures. This is a smiley face. Believe it or not, other than the fact the eyes are a little lopsided, it has even symmetry. It's an even function. Okay, I'll make a more classic one. That. It's a parabola. It's got even symmetry. Do you see how it's got symmetry? Like draw a line right down the middle. It's got symmetry. All right. How about this? Do you think this has even symmetry? Yes, it does. Okay. But all it takes is to shift it a little bit and take that V that had nice even symmetry, and when I move it like this, now it does not have even symmetry, even though it's got symmetry still. It doesn't have symmetry right down the axis line. In other words, if I were to reflect it across that line, do you get that it wouldn't like match up with itself? So even though it used to be even, since it got shifted, it's not even anymore. That's not an even function anymore. All right, so you can't just assume that if it's got an absolute value in it, oh, it's automatically going to be an even function. All right, how about a butterfly? Okay, so those are supposed to be identical to each other. If they were, would this be a function with even symmetry? No, because it's not a function. Say that louder. There's an official math way to say that. It doesn't pass the vertical line test. All right. So it's not a function. Now if I get rid of all this extraneous, extra kind of stuff here, then I could probably make a case that that's supposed to be even symmetry. And therefore, this is an even function. All right. Now, odd. Odd functions, there's only one that's easy to draw. I'll show you that first. That has odd symmetry. In fact, it's got an odd number at y equals x to the third. It's the graph of that. Does that mean everything with an x to the third power in it is odd? No. All I have to do is shift it a little bit. It's not odd anymore. Okay, but does it have odd symmetry? Yes. And here's the symmetry you have to be able to see. Imagine for a moment that there is a line going like this, diagonally. The line y equals x. Okay? Can you imagine if I take a point like up here, can you imagine going through this same point that the line y equals x did and coming out to the other side, and you see how there's another point that matches up with it right there? It's symmetry across the origin. Okay, so if I have a point here, see how I follow this across? There's another spot that it hits right there that matches up with that. Okay, so it's called point symmetry. You're used to line symmetry where, you know, you've got this shape and it's got a line right down the middle of it. That kind of symmetry is easier to see than point symmetry, but this is symmetry across the origin. Another way to think of it is, I can take this part of the line and I can flip it this way. See what I just did there? I flipped it across the line, and now I can flip it down this way and go, look at that. It matches up. It's a double flip. Now, I don't know what you like better. You can think of it as a double flip. First flip was over to here, and the second flip was down to there. It's got that kind of symmetry, which is double flip or double reflection. Or you could think of it as symmetry across this point, where you go through this point to the other side and it'll touch. I'll give you another one like that. Maybe make it a little more ridiculous. And I missed, so I'm going to try to reline it up here to make it nice. There. Okay. Now imagine, here's my spot. My spot it's supposed to have symmetry over. And if I had a spot like up here, and I go, it's supposed to match up with the point. Ooh, look at that, it does. Okay, and if I have a spot here, watch. Matches up a spot here. See? Okay, that's odd symmetry. Okay. Now, how can you tell without knowing what the function looks like? Because a lot of times you're going to give you a function like this. And we're going to say, is this function odd or even? And you don't know exactly what it looks like. You know it's kind of a U shape. It's off kilter. And sometimes they're going to work and sometimes they're not. Seriously, it's about a 50-50 on whether it'll have the kind of symmetry that you think it does. So you can't just trust your gut and say, oh, I think it's got even symmetry because it's got a squared in it. Or you can't just trust your gut and say, well, it's not just squared, so since there's more to it, maybe it's not even symmetry. Don't trust anything except test it with the math. So here is the rule, the odd rule. All right. If f of negative x is equal to negative of f of x, then it will be odd. Write that down and put a star by it. I only know one person in all my life that has had all A's in every class they ever took, including high school and college. And I asked her what her secret was, and it is not because she's a genius. I said, is there anything you can tell me that would like, she actually, I kind of expected her to say, no, I just am a good student or whatever. But she said, no, this is one thing that was kind of her thing. She would take notes, good notes in class, and then every night she would take the time to go back and look over her notes to see what the professor was trying to emphasize that day. When the teacher takes time like this and says, put a star by it, obviously that's an important thing. Probably going to be on your next test. And if you notice, I'll be doing that in class. I'll be like giving you tips that are like, this is kind of important. And when I say that kind of stuff, take the time to write it down, because that's the stuff you should look at, especially right before a test. That's what notes are for. Besides doing the practice problems with me, which is also really helpful. Helps you to actually remember it more later. All right, so there's an important rule. That's called the odd rule. So obviously that sort of begs to say there must be a what? An even rule. There's an even rule. I'll tell you the even rule. Write it down. The even rule is f of negative x, notice it starts exactly the same, is equal to f of x. And it's got the kind of the trifecta, these three ways you can do a function. Just plain function on the rocks. No, that's different. This is like neat, it's called, where you don't have any glass, or no, any ice cubes. All right, this one has got the negative, but it's got the negative on the inside. And this is the option where the negative is on the outside of the function. Okay, so they're just kind of like, it's all about how you do that. Now, To be able to do this, you have to be able to understand how to do this. F of negative x. What does that even mean? Well, that goes back to what does f of x mean? F of x. Let's say we had f of x and we had x squared plus 2x minus 9. Okay, so I got this function. That's just saying this is a function. What if I asked you for f of 2? Figure it out, please, quick. What's f of 2? Yeah. All right. What I was hoping you'd do, I don't know if anybody did this, but this is the most neat way to do it, and this is the way you're going to want to do it for today's when they get complicated. You put an empty parentheses where there was an x, and then you drop in a 2, and you see what you get. 2 squared is 4, plus 4 minus 9. 4 plus 4 is 8. 8 minus 9 is negative 1. Raise your hand if you had negative 1. Awesome. Now that parenthesis thing, you might think I'm going overboard, like, oh, come on, you can just do that in your head. Okay, but then if you just try to do it in your head, you are like 50% more likely to make dumb mistakes. And here's an example of one. Let's say I had x squared and I said x is negative 2. If you follow my advice and you just drop in a parentheses and you say negative 2 squared, you have done it correctly. If you don't take my advice and just throw a negative 2 right there and say negative 2 squared, do you get that this and this give you a different answer? Did you know that? If you take a graphing calculator and you type in negative 2 quantity, or negative 2 squared, it will tell you the answer is negative 4, and that would blow a lot of you away. I know you know that it should be negative 2 times negative 2 makes positive 4. But if it's like this, you're technically supposed to do this first and then apply the negative. So the answer is negative 4. So which is it? It's this one. It's the one with the parentheses. That's why I'm telling you, when you're doing a problem like this, you should use a parenthesis for where the x was. Because it won't be long and you'll be doing like f of banana. Little stem on the banana. There we go. Okay? You got to be able to just say, okay, I'm going to clone that thing. That means banana squared. Clone it again. Where is it? There you go. Plus 2 banana minus 9. The point is, you have to be able to put in all kinds of weird things into your function. And you need a parenthesis to be able to hold those weird things you're going to be putting into the function. One of those weird things is, let's get the bananas out of here. Oop, bounce back. Okay, is negative x. It's smart to have the parentheses. Because see, if you don't have the parentheses, then it'll read this way. And that's totally different. Which is it? It's the one with the parentheses. Because this one will become negative x squared means negative x times negative x, which makes what? Positive x squared. And then this 2 times the negative x would make negative 2x and then minus 9. You have to be able to stick negative x into a function. So, like I said, whenever you have an x, you should replace it with an empty spot. Like a parentheses. All right, see if you understood me. F of x is going to be 3x cubed minus x. I want you to evaluate that and stick in f of negative x and tell me what you get. Three empty spot cubed minus empty spot. Telling you, there's even more reasons later that I'm not getting into right now that putting that empty parentheses is really smart. Now I'm going to drop in a negative x and a negative x. And then, final answer is I got to do this in the right order. Powers have to be first, so I got to do that first. So, well, actually parentheses are, but there's nothing to do in the parentheses, so I can move on to powers. And that means negative x times negative x times negative x. Is it going to come out negative? Yes, it is. So it's going to be negative. And so then that 3, when it gets multiplied by the negative x, it's going to be negative 3x cubed. How many of you had that one right? Awesome. Most of you. And those negatives make it positive x. There we go. How many of you had that right? Okay, that's almost everybody. Now, let's do one more. Let's say the function, let's say it's not f of x. I want you to get used to that too. Sometimes it's g of x. Doesn't really matter what letter it is. Is 2x cubed minus 2x squared minus 2. I want you to figure out what would g of negative x be. All right, so I'm going to drop in 2 empty spot, cubed minus 2 empty spot, squared minus 2. Then, just how long does that take? It doesn't take that long. Kids fight me on it all the time, though. Now I'm going to drop in my negative x, and now I can carefully go through and see, ooh, that makes it negative x cubed. So that'll transfer onto the 2, and I'll have negative 2x cubed. Then this part right here would make it positive x squared. So negative 2 and a positive x squared, and then minus 2. Raise your hand if you had that one right. Awesome. Now you're ready. You're ready to actually do a typical even test on a function or an odd test on a function. So here's a function. 3x cubed minus 1. Everybody write that one down. Now here's how to test if it is odd. Do you remember I had you write down the odd rule? I bet you probably don't remember it off the top of your head, but somebody does. F of negative x equals. All right, good. Now, that's the rule. Now I got to see if this thing follows the rule. Everybody write that and draw a line down like this. On the left-hand side, we're going to figure out f of negative x. Remember that thing I was saying about always sticking in an empty parentheses? 3 empty parentheses cubed minus 1. That's my function. It's ready to take that negative x. Now I'm going to drop in the negative x. Now I'm going to take negative x cubed, and it will come out negative. So the final answer would be negative 3x cubed minus 1. On the other side, I do negative of f of x. So negative parentheses, and what do I drop in there? F of x. And what is f of x? It's this whole thing. I'm going to drop that in right here, and there's a negative in parentheses in front of it. So that means I do negative of both parts. You can't just put a negative on the first number. You got to do negative of both parts. Do you get how that becomes negative 3x cubed? And the negative times the negative makes that positive 1. And all it would take up is to mess up that one little negative sign, and you'd get this whole problem wrong. Because you'd have thought that these were equal then. But this is slightly different than that. Do you see how the tiny little difference? It's not exactly equal. And therefore, these functions, these aren't equal, and therefore it is not what? I tested for odd. It's not odd. Does that mean it's automatically even? No. Then you got to test and see if it's even. But we're not going to do an even test yet. I'm just going to have you practice the odd test one more time while I think you're pretty good at it still. So f of x equals 2x squared minus 3x cubed. Now, should that be odd or not? I don't know. We're going to test for oddness. Everybody right now, do the odd test on this thing. You need to write. You have to. This is a proof, so you've got to write this thing. If you don't write that on your paper, you can't have credit for it. That's the test that proves if it's odd or not. Okay. So first thing I'm going to do is write 2 empty spot squared minus 3 empty spot cubed. Then I'm going to drop in negative x. Then I'm going to take my time to be careful with my negatives. Negative x times negative x is positive x squared, so that's 2 positive x squared. Then negative 3, and then, oh, I guess I should start here. And that's going to be a negative x cubed times a negative 3 makes positive 3x cubed. Over on the other side, I have a negative, and in parentheses, I drop in the f of x, 2x squared minus 3x cubed. And now this negative has to get distributed to both. One's here and one over there. So it's negative 2x squared plus 3x cubed. It's really close to equal to each other, but do you get there's one little negative sign difference? They are not the same thing, and therefore they are not. This function is not odd. Now I think you're far enough that you'll understand this next part, which is if it's not odd, let's test and see if it's even. So I'm going to extend my page just a little bit here. And what's the even test? I write it right underneath the odd test, and I say f of negative x. I don't know if you remember this. It starts exactly the same way for the even test. Equals plain f of x. That's the one that doesn't have the negative. And the cool part is we're supposed to figure out f of negative x, and we already did. Do you get when we did this, we already figured out f of negative x. So I don't need to go do it again. I can just copy it right from here. 2x squared plus 3x cubed. And now I can just, like plain old f of x, even test is way easier than the odd test. I just take plain f of x, which is given to me in the original problem. 2x squared minus 3x cubed. 2x squared minus 3x cubed. And I ask myself, are these exactly the same? No, they're different by one little sign, and therefore it's not odd, and it's also, I just figured out, not even. And therefore, the function is neither. It's not odd, and it's not even, and therefore it's neither. All right. That's how you do it. Here comes your worksheet. We'll do the first few together.
It's not odd or even, what does that mean exactly?
It's neither. Think of it this way. Most functions don't have nice symmetry, right? So most functions aren't odd, and then most functions aren't even. It's more like special if they are odd or even. That's like, ooh, that's rare.
More like odd numbers.
Gotcha. I'm going to restart recording again here. So here's some help on the beginning of the assignment. Number 1, it's not odd or even. It's a question of tell with the calculator what the local max and min values are. Give the values, or x values. Give the values rounded to 2 decimal places. Okay, so I got to put this in the calculator. 4 minus x plus x squared. I know some of you have this desire to rearrange that and put it in your calculator. Don't do that. Let your calculator just do the work for you. Put it in exactly as you see it. There's no reason to rearrange it or you might mess it up. So if I put it in exactly the way I see it, I hit graph. I've actually zoomed in on mine a little bit so I can see it easily. And now here's how you find this. Is this got a minimum or a maximum? This one's got a minimum. So I go second, calculate. Minimum is the third one. Now read the questions. Left boundary. Why couldn't they have put 2 more letters on there? Boundary. Anyway, left boundary. Get to the left of it. Hit enter. Right boundary. Go to the right of the special place. Hit enter. And guess, you guess exactly where that low spot is. And I think it's about there, which is like 0.4 or something. I'm going to find out exactly. And it says 0.5000105. And even compared to last hour, I got a slightly different answer. Remember, you can round these. That's trying to say 0.5. If it's only off by, what is that, 100,000th? It's obviously trying to say 0.5. So x is 0.5. Remember, we don't care about the y, just the x. It said in the directions, the value of x, where they occur. All right, so the x value there is 0.5. That's where its minimum is. Now, technically it's 0.5 comma 3.75, but again, since our directions wanted the x, 0.5. All right, done with number 1. That's all there is to it. Just find the low spots, use your calculator to do it. Number 3, might be a low spot and a high spot on that one, so you got to find both. Oh, sorry, I just skipped 3. Number 5, I think, might have a low spot and a high spot too. We'll see. All right, moving on. Let's do one of those odd, even, neither kinds. Let's do number 7. Let's do number 7 together. Yes. Okay, here we go. Number 7. G of x is 2x to the 4th. Now, I'm supposed to tell what, if it's odd or even or neither. You know, if you have a choice, why don't you take the one that you think it's most likely to be? Because, like, if we're split testing for odd or even, which do you think is more likely? It's probably even. If it turns out to be even, we don't have to do the other test, right? So it's smartest to pick the one that's most likely to be true. So I'm going to pick the even test. So I'm going to do the even test. You wouldn't have to write that, but you would need to write this. F of negative x is equal to f of x. That's the even test. Now, I'm going to draw a line. This is supposed to be a proof. That's why we have this T-chart kind of look to it. I know you don't have much room on your paper. Sorry about that. Next, you're going to go, I want to put empty spot to the 4th. Drop in negative x. Negative x times negative x times negative x times negative x would make positive 2x to the 4th. And on the other side, it's just f of x. I just take this function, I drop it right here, 2x to the 4th. Is this equal to that? Yes. So we finally found one that's actually even. Nope. If it's a g of x or f of x, it's irrelevant. I should have stuck with the same letter, but... All right. Yay. Found one that's actually even. And the cool part was, because we tested it wisely, we chose to test evenness. We didn't go through the whole big odd test, which would have come out, no, it's not odd. But it would have wasted a lot of your time. All right. There's the basics. Backsides review. I strongly encourage you to do it. If you forgot how, come up and ask. And we got a fair amount of work time. I don't know, 15, 16 minutes. So use it wisely.